Okay, pre-calc, here we are for our third video. This is section 3 from the prerequisite chapter. We're going to break this into two parts. So the parts today we're going to look at are the product rule and quotient rule for square roots, which are very similar to the stuff we just looked at about exponents. And then we'll talk about how to combine radicals, which is essentially just like combining like terms. And then we are going to look at the last thing, probably the newest stuff for us, on how to rationalize a denominator. Okay, so starting off, the product rule for square roots is when we're multiplying common roots, and we wrote square roots here, but really it means anything cubic, quartic, quintic, anything on up. The factors can be separated or combined using identical roots. So what that means, if we had some product a and b, we could separate that into the square root of a and the square root of b, or we could actually combine them. So it works both ways. We can combine these as long as they are the same roots. An example of one that wouldn't work was, let's say we had the square root of a and the cube root of b. Those we could not combine into one. Now, the reason that we may want to do this is for something like we have here, the square root of 500. We can simplify that, and a lot of times we're going to do this because we want to think of a perfect square and the product of some of the number. So 500 can be rewritten as the square root of 100. 5, which means we can separate that into the square root of 100 times the square root of 5, which is going to give us 10 square root of 5. And so that would be a simplified radical. That's one reason why we would use the product rule for square roots. Okay, we also have the quotient rule, which essentially basically says the same thing. When we're dividing, again, common roots, the factors can be separated or combined, and in this example down here we're going to be combining to use, as long as we're using identical roots again. So same basic idea. Here we have one combined and we separate them, or if they are separated, we can combine them, which is what we said we're going to do in this one. We want to combine them, and again, the reason we do that is because it may simplify things under our square root, or our root, whatever it is. So by writing them under 1, now we can simplify 48 over 6 is 8, and x cubed over x is going to give us x squared. And we can actually use the previous rule we were just looking at, the product rule for square roots, and separate it into the square root of 8 and the square root of x squared. The square root of 8 we can simplify into 4 and 2, which means we'd have 2 square root of 2, and this will just become x. So we'd write that as 2x times the square root of 2. That would be how we would use our quotient rule to simplify. Okay, so first two, pretty quick. Combining like radicals is very quick. We're just going to do it as long as these numbers and the radicals, the roots, are identical. And we just treat that like a variable, really. So that square root of 3 isn't going to change. We're just going to look at our coefficients, 7 minus 2, and that gives us 5 square root of 3. So 7 square root of 3 minus 2 square root of 3 becomes 5 square root of 3. The last piece we're going to talk about then is rationalizing the denominator, which is not new for us, but is one that we tend to struggle with a little bit. So in order to do this, we're trying to get rid of our radical from the denominator. And we do that because when we have this here, we create what is called an error, or a compounded error, because we round off more in the denominator, and that's not what we want to round off. We want to round off at the end. So that's why we rationalize denominators. In order to do that, we're going to multiply by some form of 1. Okay, now remember, when we say 1, anything divided by itself is 1. So that is the form of 1 that we're going to use. In order to do that, we're always just going to multiply by the denominator. And you see, anything divided by itself is 1. So this is actually just the number 1, and we can multiply by 1 and not change anything, which is why this simplifies it for us a little bit. And our numerator, then, we'd have 15 square root of 6 all over, and the square root of 6 times the square root of 6 is just 6. And we can go one step further and say we can reduce 15 over 6 by dividing both by 3. So we'd have 5 square root of 6 over 2. And that would be how we rationalize a simple denominator that only has one term. It gets a little more complicated when we rationalize a denominator with two terms. And in fact, we need to use something called the conjugate, which is the opposite here. We're going to change that middle sign. So the conjugate of 7 minus the square root of 5 is 7 plus the square root of 5. And we're going to multiply both the numerator and denominator by that conjugate, and that way we're still multiplying by 1, and yet it's going to simplify our problem so that we don't have a radical in the denominator. So the conjugate here is 4 minus square root of 5 over 4 minus square root of 5. And we're going to have to distribute that 8. So 8 times 4 is going to give us 32 minus 8 times the square root of 5. And then on the denominator, the way this is always going to work, a plus b times a minus b is always going to give you a squared minus b squared. And in this case, a is 4 and b is the square root of 5. So this would end up with 16a squared minus the square root of 5 squared is 5. So we can simplify one more step. 32 minus 8 square root of 5 all over 11. And that would be our rationalized denominator, so that now you see we don't have a square root in the denominator, which means we're going to have less round-off error, which means our calculations are going to be more accurate. And that is the big part for this lesson, rationalizing the denominator. The other stuff is not really new for us, and hopefully we'll pick up pretty quick. All right, we will see you next time in class.